Hello students, my today's topic is conjunctive normal form or clausal normal form. But before starting today's topic, let me explain some terminologies which is very important to know before CNF or conjunctive normal form. These terminologies are, the first is literals. A literal can be either an atomic sentence or the negation of an atomic sentence. So as you all know, the atomic sentence can be represented with some prepositional variable. So here P and negation of P are called as literals. The second terminology is clause. A clause can be either a literal or the disjunction of literals, means oring of literals. So P, not P, P or Q, P or Q or R, these are clauses. The third terminology, that is horn clause. A clause which is disjunction of literals with exactly one positive literal is known as definite clause or strict horn clause. And a clause which is disjunction of literals with at most one positive literal is known as horn clause. So all the definite clauses would be horn clauses. So if I see an example, not P or not Q or K, so here we do have a positive literal over here, so we called it as a horn clause. So obviously any horn clause can be definite clause also, because all the definite clauses are the horn clause. So you can have an idea about these terminologies, literals, clauses and horn clauses. So by that, it would be very easier for you to understand our today's topic, that is conjunctive normal form. So with simple terms, conjunctive normal form or clausal normal form, that it is the conjunction of one or more clauses. And you know, clause is the disjunction of literals. So any well-formed formula is in CNF when it is conjunction of disjunction of literals. So we do have an example how to convert any prepositional logic into clausal normal form. So we do have 4 steps. The first step, we need to remove the biconditional symbol by using the formula. If alpha biconditional beta, then it is equivalent to alpha determines beta and beta implies alpha. The step number 2, that is I need to remove this implication by using alpha implies beta is all logically equivalent to not alpha or beta. And third step, I need to move negation inwards. Means I need to move negation from this bracket to inwards. So obviously we will use De Morgan's law. So negation of alpha or beta would always logically equivalent to negation of alpha and negation of beta. Negation of alpha and beta is logically equivalent to negation of alpha or negation of beta, and double negation of alpha is always the alpha. And step number 4, I need to apply the distributive or commutative law. So as usual, alpha and beta or gamma is always logically equivalent to alpha and beta or alpha and gamma. Alpha or beta and gamma is logically equivalent to alpha or beta and alpha or gamma. Alpha and beta is logically equivalent to beta and alpha. The same happens, alpha or beta is logically equivalent to beta or alpha. So we do have an example that this is the propositional logic, well-formed formula. How do I convert this propositional logic into CNF, that is clausal normal form? So here you can see in the first step I have eliminated this biconditional from this WFF with the help of the formula. So what I did, I actually P implies Q or R and Q or R implies P. So obviously I applied the formula of alpha bidirectional beta into this and apply this on my WFF. In the second step, I need to replace this implication symbol with the help of this formula that alpha implies beta logically equivalent to not alpha or beta. So after applying this, we do have this WFF. Now in the third step, I need to move the negation symbol inwards. So obviously I will apply the De Morgan's or double negation law. So what I did, there is a negation outside in Q or R. So obviously after applying De Morgan's law, it would be not Q and not R. There is no other negation outwards. So we do have this. And in the step 4, we need to apply distributive law. That is, we need to apply and over ors. So we have done in this way that not P or Q or R, and there is already an and, so we won't change it. I need to apply distributed law over there. So not Q or P and not R or P. Now you can have seen that these are our clauses, or you can say disjunction of literals, and they have been conjuncted with each other. So you can see the result is they are conjunction of disjunction of literals. So this is now in CNF. So I hope it is clear to you how can we convert any prepositional logic well-formed formulas into the clausal normal form or conjunctive normal form. So now we need to know what are the limitations of prepositional logic. So there are some limitations of prepositional logic. That's why we will move towards our next logic representation language, which is predicate logic. So the first limitation of PL is prepositional logic only applies to the atomic prepositions. So there is no way to handle the categories, or there is no way to handle the relationships between the objects. For example, if I said A is tall, if I said B is tall, and there are 100 students who are tall, so I need to write the prepositions for each person. There is no definite rule to represent all the objects or all the objects of the same category. So this is one of the limitations in prepositional logic. The second limitation is prepositional logic is too weak and have very limited expressiveness. For example, if I said all dogs are faithful, Tommy is a dog, therefore Tommy is faithful. So how to represent this into prepositional logic? If I said P stands for all dogs are faithful and Q stands for Tommy is a dog, then P and Q cannot be able to represent Tommy is faithful. So here prepositional logic cannot work on the meaning of those sentences. So the least expressiveness of the prepositional logic again would be one of the limitation. The third is it is compositional, means that the meaning of P and Q and R only can be derived from P, Q, R, those prepositions. So actually prepositional logic assumes that the world contains only the facts. But actually the world contains not only the facts, but it also contains the objects, the entities, the relationships, and so on. And the last limitation is prepositional logic is context independent. If I said all human are mortal, then to express this all human, I need to write almost 6.7 billion statements to express it in propositional logic. In the same way, some people can run in marathon. So again, I need to write billions of statement conjunction to express in propositional logic. So these are the limitations of propositional logic, which is very important to get noticed, because in the next topic, it would be clear ki how come predicate logic has come into picture. So I hope today's lecture is clear to you. I'll be back soon with my next topic, that would be forward chaining and backward chaining. Thank you, students. Keep watching and listening.